Alrighty, folks, so you got your periodic tables out in your blue sheets. Now, your blue sheets you probably won't need till later in this worksheet as the problems get tougher, okay? But we want to make sure we are ready for our quiz at the end of the period today, which will be 2 questions like the ones on the sheet. So the very first step whenever we do a Stoic problem is we always what first? We make sure it is balanced. That's right. So let's take a look at number 1. Iron and oxygen gas make iron oxide. Please, you can put them on top of the yellow there. Thank you. Please go ahead and balance that right now for me. Let's put about a minute and a half on the clock. Get this guy balanced for me, and then we'll talk. So once you're balanced, you should find a 4:3:2 mole ratio. Okay. Now let's take a look at this problem. So what mass of iron is needed? Okay, so it's asking me for iron. So I'm just going to put a little question mark right by that. So I let myself know, hey, that's my target. That's where I'm going. To produce 3 grams of iron oxide. So I'm given that this is 3 grams. So I like to kind of write that right there. So that way I know where am I starting, where am I going. First step is if I want to do chemistry, I need to speak the language. So my balances can measure masses, but that's not the language of chemistry. The language of chemistry is the mole, right? Moles equal mass or a formula. So I'm going to find the moles of my iron oxide. So this is going to be equal to my mass of iron oxide divided by what? What's my formula weight of iron oxide? What is it? Yeah, find that formula weight. A couple of irons, 3 oxygens. Here, 160. Is that what other people got? Make sure you can get that on your own. And iron is 56, so 56 plus 56 for the 2 irons. Each oxygen is 16, so plus 16 plus 16 plus 16. You add all that up, you should get 160. And when you plug that into your calculator, you're going to get a pretty small number, and that's okay. 0.019. And what are the units on that? Moles. They're moles because we just did mass divided by formula. Moles, but moles of what? Iron oxide. Make sure you write that on there. It's so important that you don't just say 0.019, and it's very important as well that you don't just say 0.019 moles. You go even further, you say 0.019 moles of iron oxide, okay? Because there's grams and moles all over the place, so you need to distinguish between grams and moles, but there's also multiple kinds of moles, and so you need to distinguish between those as well, okay? All right, now I'm speaking the language of chemistry, and I can go ahead and use my mole ratio. So I'm going from iron oxide to, what's my target, little question mark, iron. Yeah, so it's a 2-to-4 ratio. And what do I do to a 2 to make it a 4? Multiply by 2 in this case. Sometimes you divide if you're getting smaller. So if that was a 4-to-2, you would have divided. But since it's getting bigger, you multiply. So 0.019 becomes what? 0.038. And what are the units on that now? Nicely done.
So how did you put it, the part after the ratio where you guys said 0.019
Times 2. Yep, 0.019 times 2. That's what gets me 0.038.
You divided the 3 over 160 to get 0.019.
Yeah, so 3 divided by 160, that's where the 0.019 came from in the first place. And then we multiplied that by 2 because of the ratio.
But this one's great.
Then you take 0.019 divided by 2. If that's what we're doing. So
Wait, how's it a 2-to-4 ratio?
it's a 2-to-4 ratio because you're going from iron oxide to iron. So you're going from a 2 to a 4. So you're getting bigger. So that's why it's multiplied. Now, if it was the other way around, you're going from the 4 to the 2, you'd be getting smaller, so you need to divide there. Yep. Okay. So now moles equals mass over formula weight. I don't know what the mass is, so I'm just going to leave that as X grams. I don't know what that mass is. And what formula weight do I need to use here? Which would be what? Huh? Yeah, it's just FB's formula weight, which would be what number? It would be just 56. So notice how these formula weights change. I had 160 at first because I was talking about iron oxide. But at the end, I use 56 for my formula weight because I'm just talking about iron. That's why those units are so important, because they let me know what formula weight I should be using. Hey, what do I do to both sides to solve for x grams? Yeah, so I'm going to do multiply both sides by 56. It cancels out on the right. 0.038 times 56 should give me my answer. So that comes out to be 2.13. 2.13 what? Grams, because that's a mass. And it's Fe, because we're talking about Fe at the end there.
Multiply 0.038 by 56.
Yeah, you multiply by 56, because that's how you solve for x in that equation. Yeah, we'll do number 2 here in a second. Okay, let's try number 2 together, and I'll let you guys kind of do your own thing for a little while before we get to that quiz, all right? So, first step, we always what before anything else? Balance. Balancing is like looking across the road before you actually walk across, okay? You look left, right, left. If there's not a car coming, it didn't make a difference that you looked. It was okay. But there could have been, and the results would have been catastrophic. So you always look. You always balance. And sometimes you'll find out it doesn't need to be balanced, but you should always double check, okay? Just like crossing the road. Let's do 60 seconds. Get that balance for me. All right. When I balanced, I found a 2 and a 2. So it's got a 2 to 2 to 1 ratio. That's what I found. Okay? Alrighty, so let's see here. How many grams of copper oxide, okay, so it's asking me about this one, that's copper oxide, are needed to produce 27.39 grams of oxygen? So I know this one right here. Alright. Well, now I can go ahead and get started. Which one do I start with? Do I start with copper oxide or oxygen, or how do I know where to start? Which one do I start with?
Oxygen gas.
You have to start with oxygen gas because that's the only one you have a mass for. Like, there wouldn't be anything to do with copper oxide because you don't know enough information. So I'm going to speak, if I want to do chemistry, I need to speak the language, which is the mole. So I'm going to get moles of O2. So that's going to be mass over formula weight. So that's that 27.39. And what do I divide that by? It's 32, right? Because oxygen's formula is O2. There are 2 oxygens there. Nicely done, Samaya. So I plug that in. 27.39 divided by 32 is 0.086. And what are the units on that? It's moles, because you just took the grams, you divide by the formula weight, so it should be moles. Moles of what? Of O2. Okay. So again, if you want the moles of O2, you take the mass of O2, you divide by the formula weight of O2, and that will get you the moles of O2. Yep.
Would this be a 1 to 2 ratio?
Yeah, this is going to be a 1 to 2, because you're going from here to there, so it's a 1 to 2. Remember, there's no coefficient written. We know it's just the number 1. So that would be a 1 to 2. What do you do to a 1 to make it a 2? Times by 2. Hey, real quick, just to pause. What if the shoe were on the other foot? What if you're going this way, you're going from this guy to this guy? What would that be? That'd be 2 to 1. What would you do? If you're going from 2 to 1, you would divide by 2 if it was going the other way, okay? So just make sure they're not always going to be multiplied. If your number's getting smaller, you should divide, okay? So I just want to let you guys know that. That could happen. These first 2 just happen to be multiplication. That's just a coincidence. Hi, Johnson! Alrighty. So I take 0.86, I multiply it by 2. And I got 1.72. And what are the units on that? Moles of what? Yeah, it's copper oxide, right? Because that's where we just went. Look at our arrow. Or I erased it already. So we went from here to here, so now we're talking about copper oxide. And it's really important you put those units there, because you're not going to know what formula weight to use unless you have the proper units first. Moles equal what? What do moles equal? Mass over formula weight. So we'll set it equal to the mass. I don't know what the mass of copper oxide is. That's what Mr. Pilcher asked me for. Divide by the formula weight. Should I use 32 again? How come I don't use 32 again? But that's what that was the formula weight though, right? How come don't we want formula weight again? Am I supposed to use 32?
You switched it. You went to the.
Yeah, now I'm talking about copper oxide, so it's a different formula weight. When I had 32, that was the formula weight of O2. I'm not talking about O2 anymore, though. I'm talking about copper oxide. That should be a 64 plus a 16 gives you 80. And lastly, what do I do to both sides to get mass by itself? That's right. So 1.72 times 80. I got 137.6. And what are the units on that?
It's gonna be grams.
That's grams.
CUO.
CUO, yep. Alrighty.
I thought that was.
Yeah, especially once you get a lot of practice in, you put in the work, you'll start getting better at these, and you'll kind of get into a rhythm, that kind of thing. So your quiz, which we're going to start with about, maybe 15 minutes left in the period, okay? So that'd be about 12:08 or so. That's about 15 minutes from now. Your quiz is going to be 2 questions like this. They may be multiplying, they may be dividing in that middle, the red section there. Just depends on your balancing. So make sure you balance it, and then you'll do. So you got about 15 minutes to get yourself ready for that 2-question quiz. I'll come around and check in on folks. The answer key is below this video, and it's also on your desk if you're here in person. I'll come check in. Alrighty, folks. So that is a wrap for today. So we're about to take that quiz. You folks at home, make sure you check the answer key, which is below this video. Check a couple, let me know if you have any questions. So if you're at home, that's it for today. Just make sure you're ready for this quiz when you come back.